Here in question number 16, in the shown figure, a smooth wedge is rotating with an angular velocity omega about an axis OO dash. If the particle over wedge at a distance x is at rest with respect to wedge, then value of x is equal to omega has been given to be equal to square root of 75 by 8 radian per second and g to be taken as 10 meter per second square. I'm just writing down the free body diagram here itself. With respect to this axis, this is the radius r that will be taken as x cos 37 4 by 5. So with respect to this radius, the particle will experience a pseudo force along the direction, that is m omega square r, and its component along the direction will be m omega square r cos 37. It must be counterbalanced by the force that is acting in downward direction, it is mg sin theta. So we will just equate these two forces now. So what we are having here with, it is mg sin theta, it is 3 by 5, must be written down as m r being 4 by 5 into x omega square, that to be taken as 75 by 8 into cos 37, that is 4 by 5. On calculating, we'll be getting the value of x here to be equal to x is equal to 1 meter. So for question number 16, we are having option 2 as the correct answer. Now we shall proceed to question number 17. In question number 17, consider shown arrangement of two blocks. A vertical force F is equal to 50 Newton and horizontal force F1 is applied on the blocks of mass 5 kg and 20 kg respectively as shown. If minimum value of F1 for sliding between two blocks to occur is 100 Newton, then find the coefficient of friction mu is. We shall start with the calculation of maximum possible value of the frictions between these two surfaces. Here and here to here. So here, if R1 I'm taking it to be the maximum value, it will be mu times normal. Already this is 5, g to be taken as 10, so 50 and plus 50, it is coming out to be 100 mu is the maximum friction value here. And what about this surface? It is coming out to be FR2 max, that is, this is 20 and this is 5, 25, so it will come out to be 250 and plus 5, it is 300 mu. That is the maximum value of friction force at this surface. Now, minimum value of F1 for sliding between two blocks to occur is 100 Newton. So we may almost assume that there must be some sliding at this surface. So let's say whole of the system is moving with acceleration a0. I would say a0, it must be equal to F1 minus 300 mu divided by 25. This is the common acceleration for both of these two masses, and it's already been said that at this point just state of impending motion is happening. So for this portion, the friction force along the direction, that is how much? 100 mu. I would say 100 mu divided by 5. It must come out to be a0 itself, and it is F1 minus 300 mu divided by 25. Just have the calculation here. This is 5, or I would say this is 500 plus 300, 800 mu is equal to F1, and the value of F1 to be given how much it is? 100 Newton. So should I say mu to be equal to 1 divided by 8, or I may say it is 0.125. That's the answer here. So for our question number 17, option 3 is the correct answer. Now we shall proceed to next question, that is question number 18. In question number 18, 2 point masses each of mass capital M are attached at the end of a light rigid rod AB of length L, and system is placed over a smooth horizontal surface. If a horizontal impulse J is equal to mv is given to point mass at B as shown, then velocity of end B just after the impulse and angular velocity of rod omega will respectively be. For this system, this impulse J is equal to m, V was applied here. Let this being the center of mass, I would say. So how much would be the velocity of center of mass effectively? It will come out to be capital MV divided by how much? 2m, that is the velocity of center of mass, and that is coming out to be V by 2. It is V by 2. Now with respect to center of mass, the angular impulse that actually being provided, that is mv, and this distance being L by 2. So This angular impulse will generate the angular momentum here, and the final angular velocity, if it is omega, then I would say momentumness about this point is how much? It will be m, this distance is L by 2, so it is L square divided by 4 into 2, it's coming out to be this much. Or equating this part, this will cancel out, m will cancel out. We are having the value of omega to be equal to v divided by L. Now, what we need to calculate, velocity of end B just after the impulse and angular velocity. We have calculated the angular velocity to be equal to v by L. Now, velocity of this point B will be, velocity of point B with respect to ground will be, velocity of B with respect to center of mass, that is coming out to be v divided by 2, and velocity of center of mass with respect to ground, that is v by 2, so it is v. So we are having option 3 as the correct answer for question number 18. Now we shall proceed to next question, that is question number 19. In question number 19, a uniform ring of radius r is rolling without slipping on the horizontal surface with angular velocity omega is equal to v naught divided by r. If VA, VB, VC, VD denotes the velocities of point A, B, C and D respectively, then choose the incorrect statement. Here we have been provided with the options of the difference of the velocities of the different points. Let's consider one by one of the option here. What we know at least, that with respect to ground, this point shall have the velocity 0. This point shall have V naught along the direction, V naught along the direction. This point shall have 2 V naught along the direction, and this point will have V naught and V naught along the direction. With this pretext, we'll be taking the option 1 here. VA minus VC is equal to 2 V naught. This point is A, B, C and D. VA minus VC. Definitely this is 0 and this is 2 V naught. So option 1 is the correct one. Similarly, VB minus VD. This point being B, this point is D. So we shall have the difference of these two parts will be 2 V naught. This is also the correct option. And third one is VA minus VD. A and D. So with respect to this point, it will have the velocity along the direction, that will be how much? Root 2 V naught. So this one is also the correct option. VB minus VC, this is B and C. So difference of these two parts will be root 2 V naught. And VD minus VC, D and C, this part shall also have the difference of root 2 V naught. But it's been said that this is not equal to. So this one will be the wrong option. But here in this question, we need to mark the incorrect statement. So for question number 19, we shall take option 4 as the correct answer. Now let's proceed to question number 20. In question number 20, a particle of mass m is moving along the line y is equal to x with constant velocity v naught. Its angular momentum about the origin is. Very straightforward situation. This is the path on which the particle is moving, and this is the point origin here. So about this point, we are not having any perpendicular distance of this line of motion. So angular momentum will be how much? It is 0. So for question number 20, option 1 is the correct answer. Now we shall proceed to the next question, that is question number 21.